Hello AI lovers, I am back with a new topic that is called different ways to remove outliers. And if by the way, if you don't know what are outliers and how to detect outliers, please check my previous video, link is in the description. That would completely tell you what are outliers from scratch and how can we detect outliers. So far, I'll assume that we have detected outliers, and today we are just going to learn how can we remove outliers, different ways to remove outliers. So we'll start with recap, and then we'll discuss some methods of removing outliers, and then we will practice it, practically by using Python. If you are new to our channel, welcome. We make courses and videos for exactly beginners. If you're going to start your career in data science or artificial intelligence, you're more than welcome over here. We have made a lot of courses on data pre-process, from data pre-processing up till machine learning, deep learning, CNN, RNN, and reinforcement learning and deep reinforcement learning and stuff like that. So please check out our channel AI Sciences, and you're welcome. So we are going to learn. So first of all, we are going to learn the methods of removing the outliers, right? And first method is you can just remove the rows that contain outliers. And secondly, there are some statistical methods that help you not removing the rows that contain outliers, but imputing some values in the rows. What are those values? We'll learn that in a minute. So first of all, let's talk about method 1, which is simple and easy method. Just remove the problem, just remove the outlier. Outlier is a problem, so remove it. So its benefit is it is easy to do. You just have to remove the whole row. So let's say these are the columns, and this is the column that has an outlier over here in this cross. So you just remove this whole row from here, and we're good to go. So it is easy to do, and then it is also more effective. Your whole data nature is same. Data size would be changed, but data nature is same. And its con is it doesn't work well on small data, which means if your data is already very data amount is very small, and you will remove some rows from it, it will become even smaller. And if you're using deep learning, I think that would be a problem. It just shrinks the data because it removes the rows from the data. But if you have a lot of data, you're good to go. You can just remove the rows. So let's go to Python and let's practice it. So previously we had data that we have done a lot of practice on detecting the outliers in previous video. Again, check the link in description. And now we have outliers in a variable. So these are the outliers. Oh, these are too many because we had used threshold of 2. Let's use threshold of 3 so that we have only 8 outliers. Yeah, so we have only 8 outliers, and let's see how our data looks like. Boost and data frame. Perfect. So we have these rows that contains outlier in RM column, remember, right? Because we were working on RM column, right? So let's go, and removing the rows that contain outlier is just very easy. So removing rows. So what we will do is we'll write the name of data frame, boost and data frame dot. So this is a pandas data frame, right? And we'll just say drop. By the way, if you're having some difficulty in understanding the syntax of Python, you can check out our complete course for the beginners that explains Python to even those people who doesn't know coding in any language. So it starts from that much scratch level. So you can check out that course, and it goes up to advanced level. So we will drop the rows. Which rows we are going to drop? Outliers. So these are the rows that we want to drop, and access would be index. So we are adding index to it. So these are the indexes, right? Indices, right? So let's just run it, and here we go. You can see that now our total rows are 498, and originally total rows are 506. So 8 outliers have been removed and remaining rows are 498. So that's how you can just remove the outliers. And if you want to remove the outlier and you want to update your data set as well, you can just say in place equals to true. So you can just run it and it will, and right now, you know, without this, your original data frame looks exactly same. It doesn't make any change to original data frame. But if you want to make this change and drop these rows into from the original data frame, you have to use this in place true. So it will, you know, in place all the changes. So right now I'm not going to do that. You can do it at your own. So sorry. So far we have learned how can we just remove the rows from the data that contains the outlier. Now we are going to learn another method, another statistical method that helps us in imputing the data rather than removing the rows. So if we have small data set, then this method is going to work perfectly fine, because its benefit is it doesn't shrink the size of data. It doesn't remove any row. It just replaces some of the values. And its negative point is data will become unimpure, because let's say this is the data, right? And here is an outlier. You're not going to just remove this row. You're going to replace this value, right? Replace this value with some of these values: mean, median, and mod. So what is mean? Mean is the average value of any, let's say, column, and median is the value that comes in the middle. If we sort the column, any value that comes in the middle, that is the median, right? And mod is the value that occurs the most, right? So let me say most occurred value, right? That is the mod. So let's go into, by the way, let's practice it a bit. So let's say I have a number 1, number 2, again 2, and then let's say 3, right? So what will be the mode value from this? Let's say it is a list. What is the mode of this list? So most occurred value is 2. So its mode is 2. So what is the median of this value? So which value? First of all, we have to sort this list. Fortunately, this list is already sorted. So which value comes in the center of this list? That is the median. So these two values are coming in the center of the list. You can call any of these values as a median, or you can take the average of these values in order to call them median. So fortunately, these both of the values are the same, so you can call it. So you can use any of the value as a median. So how can we calculate mean? It is simple average formula. You have to add them up. So 3 plus 2, 5, 5 plus 2, 6, 6 plus 1, 7, 7 divided by total number of occurrences. So 7 divided by 4. So I don't know what is the answer of it. You can calculate it. So that's how you calculate these values. And now if you want to replace this value with anything, if 1, 2, 2, so let's say 1, 2, 2 and 3 are the columns, and you want to replace this one. So 1, 2, 2, 3 are the values. You want to replace this value. If you will replace it with mode, so 2 will come over here. If you will replace it with median, again 2 will come over here. And if you will replace it with mean, almost 2 will come over here, something near to 1.9 or something, right? So let's go to our coding environment and let's implement it. Let's call it imputation. And here what we are going to do is, first of all, we will calculate the mean of what? Of Boolean, mean of Boolean data frame. How can we calculate it? We have to calculate mean of column RM. This RM is not a function, it's a column name, and we have to calculate its mean. It's that simple. And then let's copy and paste it a couple of times because we have to calculate median and mod as well. So median would be data frame dot rm dot median, simple. And mod would be, any guess? Mod would be again the same thing, we just have to do this. So it will calculate all the values, and let's just print these values. So let's call it mean is this, right? And then median is, let me add next line to it, \n. It will add a next line to it so that it looks nice. So median, and then again next line and mod, and here we'll display the value of mod. By the way, if you add a space after this comma, it just looks nice. It is a standard of Python community. So here you can see its mean is 6 point this, median is 6 point this, and mod is, here we go, you can see that a lot of values are available over here. What does it mean? So it means that these are the values that occurred the most of the times, but the number of their occurrences is same. So you can use any of these values. So let me use, let's say, practically speaking, so if you have a list of like 1 1 and 2 2 and let's say 3 and 4, right? So if you have this list, so what would be its mod? Its mod would be 1 and 2, sorry, 1 and 2, because 1 is occurring 2 times, 2 is occurring 2 times, and rest of the figures are occurring only 1 time. So that is exactly what has happened over here, and we are just fetching its, let's say 0, let's get its last value. That's how you get the last value, by using negative indexing, but it is showing us an error. Okay, so it is not a list, that's why it is showing this error. So let's get this value, and it says this one. So if you want to get, let's say, last value, what is the index of last value? It is 5th index, and that's how we will simply get the last value. So now we have mean, we have median, and we have mod. Let's just replace it where we want to replace it. So let's do it very simple way. Let's use ancient method, which is using for loop. So for I in outliers, right? So it will iterate over every outliers. By the way, these outliers are not the numbers. These outliers, this is a list that contains the indices of the rows where outliers are occurring in RM column, right? So here we will say in booster data frame dot iLocation, iLocation means index location. Which index location? Row number I, right? Row number I, and column name is RM. Do what? Replace it with mean. Simple, one line solution. Let's run it, and let's display our data set over here. I think we should display all the dot iLoc. We should display all the outliers that were previously outliers. So let's display them. Here you can see that we have replaced it with the mean, and all the this is displaying only all the outliers, only 8 rows, right? So in RM column you can see that all the outliers are have been replaced with this mean value. So if we want to replace it with median, it's just as simple, and let's just run it, and you can see that 6.20 and median value was 6.20. And if you want to replace it with mod, let's just run it again. Ta-da! Here we go. So it has been replaced with mod as well. So that's how, guys, you can remove the outliers. You can just remove the rows, or you can, if your data is not a lot, then you can impute the values. But imputing the values may add a penalty, because you're not sure if this is a right value for this column or not, but this is approximately right, most probably right, you can say that, right? So your data is impure right now, but it looks comparatively fine if you don't have a lot of data. Now one question is left. You may be wondering that where should we use mean, where should we use median, and where should we use mod? So there is no, theoretical answer for it. It just depends on the nature of data. For example, if you have to replace the final marks of the students in a class, right? So if marks of one student is missing, you may replace it with a mean. I think it would be fine. But if you have values of, let's say, some patients, so let's say zero denotes that patient don't have cancer, one denotes that patient has cancer, and 0 denotes that patient doesn't has cancer, 1 denotes that patient has cancer. So if you will replace it with mean, it will show value something like 0.5. That is not good enough. So maybe you want to replace it with mod, I think, because 1 is occurring most of the times. So if any value is, let's say here value is missing, you can replace it with mod, which is 1. So that's how that is exactly the theory. You just have to look on the data, and you have to have some domain knowledge in order to know which statistical method is good enough to impute data in your outlier cells. So that's about it. We have done, by the way, we have done practice on Python as well. So please hit the subscribe button and hit the bell icon as well, so that you can get the latest uploaded videos from AI Sciences. And do check our courses as well that are made for you. Thank you.